Let's consider the experiment flip a coin 4 times, and let's find the probability that the result will be 2 heads and 2 tails. In order to understand the process, we might first begin by drawing a tree to describe this experiment. Our first flip could result in either a head or a tail, and then our second flip could result in either a head or a tail. And then again, our third flip could result in either a head or a tail. And we've got a tree that's starting to expand and pretty soon could get out of hand to the point where we wouldn't be able to draw this out anymore. Here's our fourth flip, but we can at least, in this little space that we're working in here, we can get out to 4 flips without too much trouble. And then either by counting the ends of these branches or by using some counting methods, we can determine that there are 16 possible outcomes here. And because the probability of throwing a head or a tail is the same, they're both a half, then each of these 16 possible outcomes are equally likely. So if we're to find this probability, then what we need to do is find the number of these outcomes that contain 2 heads and 2 tails, and then divide that by 16. So we could go through here and kind of count them. We've got head, head, tail, tail. That'd be one way to do it. Head, tail, head, tail. But that's not a very organized way to do this. One thing that we might do is think about, well, basically what we're doing as we go through those branches is just look at all of the possible things that could happen. We could either get 4 heads, or we could get 3 heads and 1 tail, and that 1 tail could occur in the last throw, the second to the last throw, the second throw, or the first throw. And then we could get 2 tails, so we could get 2 heads and 2 tails, and this is actually the ones that we're looking for here. And they could happen in different ways. We could list all these out, all the different possible ways that we could get 2 heads and 2 tails in this sequence here. We could get a tail, a head, a tail, a head, or 2 tails and 2 heads. And I believe the one we're missing is head, tail, tail, head. Or we could have 1 head and 3 tails. And that head could be first, second, third flip, or the last flip. And then the only other possible thing that might happen is that we could have 4 tails, this last branch here. And if we've done this right, we should find 16 outcomes here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have all 16 here. And what we find is that 6 of those, these listed here, have that particular characteristic, that we have 2 heads and 2 tails. So that probability, the probability that we would have 2 heads and 2 tails, would be 6 out of 16, or 3 out of 8. Now we understand this theoretical probability. But what we want to do now is design a simulation that allows us to estimate this probability.